Microplastics are an increasing environmental problem because they can behave as fomites, which are inanimate items that carry disease-causing organisms like viruses and bacteria, pathogens, and chemicals. Microplastics pollution has contaminated the entire planet, from the summit of Mount Everest to the deepest oceans. According to a study conducted in Rize, Turkey, microplastics cause damage to human cells in the laboratory at the levels known to be eaten by people via their food. A study has found the harm included cell death and allergic reactions, and the research is the first to show this happens at levels relevant to human exposure. A qualitative investigation of an edible bivalve, the Asian green mussel, Perna viridis, cultivated in Bacoor Bay, Cavite, Philippines, was conducted to assess the presence of microplastics. Microplastics were discovered in the soft tissue of acid-digested mussels after microscopic inspection. Based on the data elicited through survey, needs analysis, and the review of literature, we defined the complex engineering problem as follows. Microplastics as ubiquitous environmental contaminants. Microplastics are varicidal, which might be consumed by low-trophic fauna. Microplastics have recently been detected in drinking water and its sources. In alignment to the Sustainable Development Goal 14, Life Below Water, the researchers considered the Barangay Binuangan to correspond best in this endeavor. Binuangan is a barangay in the Philippine province of Bulacan's coastal municipality of Obando. It is an island of the shore of Manila Bay, north of Isla Pulo, Tanza, and Davotas, in an estuary formed by the confluence of the Binuangan and Luzon rivers. With their geographical location, it is very evident that the job of the locals is primarily centered in aquaculture. In relation to this, the group aims to design and develop an efficient prototype for real-time detection and quantification of microplastics using a deep learning model to ensure clean and sustainable management of water, which meets the goal of SDG 14, Life Below the Water. The system's hardware main components are metal frame, camera, petri dish, and ring light. The researchers used YOLO version 4 algorithm in developing an object detection model, specifically quantification and identification of microplastics. Google Colab was used in training the model. For the microplastic program application, it is located on the left bottom side of the desktop. Click it to start. After clicking the microplastic program, the graphical user interface or GUI screen will appear. At the bottom left part of the GUI, there will be the microplastic count, a ratio between the total number of microplastics to the total number of residues in a certain frame. On the other hand, the bottom right of the GUI displays the number of small, medium, or large microplastics in a certain frame. This sums up the total number of microplastics at the bottom left part. The figure shows microplastics as identified particles with a blue box and labeled as MP. It also shows the level of confidence for each residue. The microplastic count will flash and count various sizes at the bottom of the GUI. As you can see, it shows a frame with microplastics and non-microplastics detected. Non-microplastic residues are recognized by the red boxes labeled as NMP. It also shows that the system can also detect overlapping residues, which indicates that the model sensitivity is high. The sensitivity measures the model's ability to detect positive samples. In this case, the model is able to detect a microplastic even when they are touching each other. The system may also detect transparent residues, as seen in the figure. Transparent surfaces are difficult to detect since light passes through them. However, transparent residue may now be detected easily using the project. Microplastics are everywhere, but many people have no idea what they are or how prevalent they are. Microplastic pollution is most likely not local, but rather regional and possibly global in scope. If we do not start recalibrating our habits and redirecting our actions towards the ever-growing microplastic pollution, human and marine life will be at risk. Continuous project development concentrating on the answer in eradicating microplastics is critical. With the support of the capstone design project created by proponents, let our micro efforts lead to macro effects in managing and protecting marine coastal ecosystems from pollution.